Hello. Ah, ah. There we go. Sorry about all that, guys. I had to eat something before we started talking. We're gonna have a look at what I want to have a quick look at if you guys ended up doing so I will actually use words now. We are going to be looking at statistics or we were looking at statistics, and there's a pre-recorded video on this. I would like to first of all go over some class logistics stuff, and then there was one in-class activity that I wanted to look at. And I'm wondering if there was something that we forgot or didn't do last week that we wanted to do this week. So let me see if I can. I'm just going to find the in-class activity right now, and I will go from there if people did that one. Do class submissions and stats and data analysis. And okay, so we have 4 people that submitted something to that. So thank you very much for that, by the way. And we can go from there and we can talk about it. So first of all, let's see how people were doing with the class so far. I know that last week was very stressful for you guys. It was not meant to be that stressful. I apologize on that. So let me put up my disclaimer on this one. I even talked to about with the first group today about online classes and COVID and doing things remotely. And it also perhaps dawned on me more than I thought it would. One of the issues that, we have with these kinds of classes, and maybe because I'm biting off more than I could chew or I should have, is that these classes are designed for, like, when you're designing an online class, you have to build everything, throw it out there, and then say, like, okay, now let's do these various parts. And as you might imagine, if you suddenly went from it being an IT class with predominantly programmers to predominantly, like, half the students here are about Tim students, the demographics are different, the requirements are different, everything is, different. That's not to say that we can't shift things. And then when I also had a wrong mental model. When we looked at it, I was told, sort of the director of our department said, it's 1.5 times an undergraduate class. And then when we all talked about it in the faculty meeting yesterday, people are like, yeah, it's about 10 hours of work. Okay, that's way less than the 15 to 20 I was told. So I'm more than happy to shift. I'm more than happy to try and adjust things. I still want to do a project. The reason we need to do a project is that's where you get your hands dirty. That's when you sort of figure things out. But it's not meant to be this Herculean task or this overwhelming course. It was never meant to be that, but I can understand or appreciate or empathize how what felt like that last week. That's why homework 3 and 4 are, they're not. We are making 2 out of the 5 out of the 6. I guess it's got to be 6 homeworks optional. So if you do homework 3 and 4, hey, you can make the other ones optional. I like homework 5 and 6 simply because it's drawing with pencils and crayons, maybe some glue and some sparklies. All right, it's designed to be just playing with the idea of how you represent data visually and not have the benefit of Tableau being able to do all the colors for you. Every single thing you draw on this thing is very exact, and you have to think through the process. And since it's on paper, if you do something wrong, So I like that Dear Data project that's coming up after some of the individual homework 5 and 6. You make one of these things and then you trade off with another person in the group anonymously, and then you critique what they did to give them feedback to improve. And that's also anonymous. We know who the people are, but you don't know who you're sending it to, and they don't know who they're sending it to. And so you're just trading off information. So that is coming up later on, but right now we're going to be in the thick of dealing with the project. So project 2 is figuring out the task, which is pretty big. I'm hoping that the interviews were helpful in many ways for you guys. And then after that, it's just building up, the server side and the front end, that sort of thing. I don't I want to make sure that people are not biting off more than they can chew. So when a group A, and by the way, I don't think I officially asked for this, and the Space Invaders, the astronomy group, I guess volunteered this, and I'm like, oh yeah, I was meant to ask for that. I would love to get group names for you guys if you want to have a cool, awesome group name, Team Super Cool or something like that. Just because I think that it's a lot easier than saying Group A, right? Group A is ends up being COVID productivity for STEM, women in STEM. And they're when I looked over their project, realized, well, they're actually saying they might do the analysis in Tableau. They may have to do some back end stuff to clean up their data, but that's okay with me, right? And so if you have something, I know one group is looking at Orange as a potential analysis tool. If you have things that are going to help you that you already know, let's go with that. Let's go path of least resistance for this project if we can. I wanted to give you guys exposure or yeah, initial exposure to programming, just in case you haven't been doing it before, just to give this just another skill set for you to learn. But I didn't want it to be tear inducing. So if you can find things that will make your project work, the key is it can't just be sort of a turn the crank solution that there's no thinking involved. It has to be something that you have the task, you have what you're trying to plan out for your project, and you have to be dealing with the data and interacting with the data, or somebody has to be interacting with the data along the way. So if that involves making a Tableau visualization that you put on a website, great, that'll do. You still have to clean the data, you still have to do the analysis, you still have to, post this thing. If it involves you doing a Jupyter notebook, great. If it involves you making a website, great. You will be hitting all of those parts of the project, whether you want to or not. If and for some of the projects, the data behind the scenes is pretty clean, in which case I would expect a bit more stuff on the front, on the front end. If you have to do a lot of data cleaning, that's a big task, and that's something that when you're writing up your project, especially at the end, it's a holistic view of what you've been learning and what you've been doing along the way. So if something is a major time sink, but it needed to be done, so you're doing tweets and you're trying to figure out what the sentiment of various tweets are, that's huge, right? That is part of the project. And you're talking about it from the perspective of how you're getting the data, how you're analyzing the data, how the person involved in that process is being involved. Not the, I do want to know what the machine learning algorithm you're using is, but it's not a machine learning algorithm course. Heck, it's not even a visualization course. I want the interaction with, it is a visualization course because the person's viewing it, but it's, or visualization is critically important for some cases, but it's more about how are people dealing with the data and how the journey that you're walking along. So that's my perspective, at least on this. That's what I'm looking for when it comes to the final project. I want to see how you walked along this path, not whether I'm not wanting people to say it was perfect, there was no problems ever. It is, your journey is actually telling me how well you thought through the problem. Your journey is also telling me what you've learned in the class, and ultimately that's what you're taking away from the class. I'm not expecting perfect solutions. I'm expecting people to be trying their best, and then we'll adjust and we'll fix things, and we'll learn from mistakes along the way. That's how most of these projects should end up going. I wouldn't expect you to have for project one, this is a perfect, already made, polished solution, go, right? It's not. It's an iterative process. Okay. So that's at least my perspective on this. If you can streamline your project to make it easier for you, while you still have to be dealing with, you can't just take a pre-existing solution and just show it to people or something like that. It has to be something that you are building a project, but as long as it's meeting the task that you're wanting for your users, then I think I can get on board with a lot of different things. There's no one size fits all project for this course, right? That's sort of the point of a grad course, is that you have that little bit of flexibility so it can match your interests and what you also have the background skill for. Can I, that was a long meandering talk. So can I unpack something for anybody? Does anybody have any questions about the project, or what the expectation is, um, homework assignments, anything like that?
Yes, Professor, I have a question. I have done the first part of homework 4, and for showing the chart with Altair, we need to add some comments in Jupyter because the I think the HTML doesn't support some package. I don't know, something like this. After I put the comments in my code. Um, Unfortunately, my Jupyter notebook didn't doesn't show anything, and I have some problems with my Jupyter. And I was wondering if I can use Colab Google Notebook instead of um, Jupyter for my second part. I have done the first part and I show the chart, but after that I can't use anymore my Jupyter. It doesn't show my data frames or this kind of stuff.
You could just could you make a brand new, is there any way to divorce it into multiple different Jupyter notebooks? If that makes it easier rather than all just one Jupyter notebook. Um,
Mm, yeah, I
um,
know. I am creating new Jupyter notebook for the second part, but it doesn't work, and
mm.
it is very bad situation.
So if Google Colab works for you, but I originally actually was planning on using Colab to for this course. And I was like, I'll have to learn that just before teaching the class. Oh my God, that's going to be pretty intense. And so I chose, hey, this is going to be too much I thought it might be too much for students. And then I'm glad I didn't do it. If you know Google Colab and you can do it, I'm okay with that. Just make sure you leave it like a note for the TA when they're grading it saying I said it was okay.
Yeah,
Uh,
I know. I don't know Google Colab because I always use Jupyter for my courses and my thesis and these my works. But now because I think fixing my Jupyter it is time consuming, and I think I can't catch the deadline. So
I
I
just
was
say
wondering.
I would say punt on the homework personally, but um, I don't know why it would not work at all beyond a certain point. That seems really strange.
Yeah, it is strange for me also because I search and type some other comments. Some people said that you should reinstall the Jupyter and these kinds of tests. I do all of them, but it doesn't work. And
Oh my God. I thought it was going to be Anaconda is supposed to make these sorts of things simple. Anaconda is just meant to bundle up, in case for those of you that don't know what I'm talking about with Anaconda, it's meant to just be bundling all of the fiddly diddly crap that's associated with Jupyter notebooks and Python and all the disparate different technologies that data scientists use. Anaconda just allows you to have a one-stop place for to make sure that the versions of all your different programs are correct and updating things, because otherwise you'd
yeah,
spend days just updating it constantly. So I would just double check. I mean, you could double check your Anaconda settings just to make sure that everything's up to date as well. It would be my first pass on that one as well.
yeah,
Um,
maybe I should check it again. I didn't check my Anaconda. I just because I use terminal and I just type Jupyter
oh,
notebook and like this,
yeah.
So
If you're using a terminal, the versioning is going to kill you, right? Every single
yeah,
thing you'd have to update and I'm not the person to help. I don't do like as soon as it goes command line, I start just crying uncontrollably. Just bad. It's like, oh God. Um, so yeah, I've been using Anaconda because it helps control packaging and versioning of all your various programs. But I don't want to force you into one way or the other, but it might be you have to update your Altair and
yeah.
all the various packages.
Mhm. Okay.
Okay.
But
I wouldn't go into Colab. And if my personal view on this thing is try as much as you can, pass in what you can, and punt as soon as it starts taking more than like a half hour for you to try and update things or to get things off the ground. If you get stuck on something, punt on this one. Enough people have had to just sort of ignore homework 4 that and the fact that we're making them now optional,
Mm.
move on if you need to, because I don't want you waste. I don't want people spending like 20 hours
Oh
figuring
yeah.
out something to find out, like, you know, that you may or may not find useful. It was meant to
Mm.
be, 5, 6 hour exercise. Even that now in retrospect seems long. Um, but I think there's um, and I just want to double check the attendance here. Okay, so I know they also had some complaints about grading being too harsh, and I'll talk to the TA. I want to talk to the TA about this first, to get his perspective on things. But I think part of it was a miscommunication with me saying, like, look, when we look at what you write for, let's say, a description of, or a discussion of the visualization zoo, it should show that the person actually thought through or read the paper. That seems like a reasonable assumption. He interpreted that as I'm assuming he interpreted that as you have to be directly addressing some part of the paper to show that you actually read the paper, which is not what I said, but I can understand where that miscommunication happened. So we had some great discussions, or you guys had some great comments on things, but there was also some people that posted things that were like, you read the abstract. I know you only read the abstract. That's all, like, that's pretty clear. Uh, that is not, so that would be not acceptable. But if you guys have a discussion and it's a reasonable, meaningful point and you read the paper, you should be getting the points. That's my view on this. I'm not trying to nitpick on how many points you get for things. So for the Project 1B, I actually have to give you your actual grades for Project 1B. They are not the percentage grades I gave you guys, because the percentage grades are where I think approximately where you're landing when it comes to the amount of thought through the project. That is not the same as you checked off all that, like you did all the things you needed for the points for the project. So if I think you needed to think through the project a bit more and think through the details a bit more, maybe you got an 80% or something like that. That does not mean that you get an 80% for that project. I mean, you might get 100% because you did all the things I asked for. I'm just giving feedback on where you could improve. And so, Tina, to go back to your original thing, I don't want you wasting a large amount of time on the coding unless you really want to, but I don't want people panicking over the coding either. So I would just I would look at versioning first, and then if you can't get it off the ground and there's not an easy solution, I would just move on if you can. I know I can't move on myself. I obsess, but if you can, move on if you're getting stuck.
Yeah, it is because of my bad chance, I think, because this homework was very simple for me, and I don't want to lose my chance in, yeah,
Yeah,
you
if it's a
know.
simple homework, you're probably better at this than I am with that homework. So, yeah, it could be just bad luck in terms of versioning. I know Altair it's relatively new, so it's still
Yeah, yeah.
um, unsteady state.
I always use Matplotlib. It was new for me, but after the first part, I don't know what happens, and my Jupyter crashed, and oh my god, all of my works are with Jupyter, and I don't know what should I do
It
now.
crashed. Oh my God. Okay.
Yeah,
Yeah, I mean, I look at new versioning, and I'd also separate the first file from the rest of the stuff that you're doing,
yeah,
so
yeah,
that
yeah, yeah,
you can separate your concerns.
yeah.
Okay. Other questions about homeworks, projects, that sort of thing. I want to make sure that we're fine. I only wanted to go over the in-class exercise. Well, I'll briefly talk about the stats stuff first and see what you guys' thoughts on it were. Because I don't know where your stats background is. Uh, so, for example, I do not know how many of you have had to take statistics at some point in time. I don't know how many people have done a machine learning algorithm or a machine learning course. My machine learning lectures are probably like, oh, that was sad, man. He shouldn't be talking about machine learning. It's not my area. And if you've taken a course in machine learning, you probably have a clear view of what it should be. Demand.
Hey, David. Yeah, I was wondering that in your schedule it says project help for session 6 and 7. So we as a group have some questions around the feedback you gave us on the project initially. So I was
Okay.
wondering for using that time for project help, do we need to schedule something, or we just need to show up in the lecture and that's how it goes?
Oh, I was thinking just show up in the lecture unless there's something I
Okay.
really, yeah.
So
And you
those
also,
two lectures, sorry, yeah, go ahead. Sorry, I didn't mean to interrupt you.
no, I think that's, unless I'll have to think a bit more, because I think, again, there's a certain
Okay.
amount of improvisation you have to do, because you don't know if people are going to hit problems with project 6 and 7. But I think most of the time at that point in time, people are still, you're trying to polish things. You're trying to unstick yourself in certain areas where things
Right.
go wrong. Your data doesn't work out, or it doesn't work the way you expect it. And therefore I wanted that time dedicated to,
Okay.
students coming in and be able to chat with me about things.
Okay. Sounds good. Okay.
Nice. Oh, Adrian B.
Yeah, I just was hoping to get a quick clarification about just like the schedule for in class, just because I think I might have gotten confused. I'm not sure. I thought this week we were discussing lecture 4, the data collection and cleaning. So I was just wanted to make sure that next week we're supposed to go over the in class for lecture 6 then.
Let me look at the AR asynchronous lecture, because I thought I was data. This was 929 is Intro to Jupyter Notebooks. Data collection and cleaning is lecture 4. And then 1006 is statistics, aggregation of data, and Tableau, and data analysis and processing, which is, everything. It's a huge number of lectures. This is a bit, I will say, I fully admit, I'm being a little bit long-winded in the lectures, and I probably need to give you fewer lectures afterwards on the visualizations of things, because I'm really getting long-winded, or I'm always long-winded, but I normally have a class time to limit me. So I'll try and make sure that I keep things down to a dull roar. I think this week's worth of lectures was too much for a single week's worth of lectures, but it just, I think next week's are much shorter, so you can, if you didn't watch all the statistics videos, you can always push it off to next week, I think. Right now, this week was supposed to be, according to the schedule, statistics.
Okay. So next week will be the database, lecture 6.
Yeah,
database
which
and
is
information seeking. Okay.
And that's just, if you're a database person, you're just going to laugh at me. It's fine.
Okay. I just wanted to clarify. Okay, thank you.
Yeah, like NoSQL databases and the like. It's not, it's one of those. I will learn it later when I need it, right? I like my former supervisor, my undergraduate supervisor. I said, "Hey, have you learned C++ yet?" Because I was doing it in industry, and he said, "No, I'm waiting for that fad to end." And that sounds like a naive answer, but it's not actually a naive answer. That's the right answer for computer scientists or for anyone dealing with technology. There's too much. And so you learn it when you need it, when it comes your way, and you have to deal with it. So NoSQL databases, I'll learn it when I need it. But I mean, I learned enough to know about the technology, but I've never made a NoSQL database. I've never set one up. But I know enough to be dangerous. So that's fun. So any other points to bring up first? And then we'll go on to what I was going to talk about. We're going to do a brief little discussion about the stats. Does anyone have any, I'm trying to get a sense of statistics. So for the TIM students, do you have to do any kind of statistics? Yeah, what kind of statistics?
It depends. The MAP program, I mean, the Master of Applied Business Analytics, we have to have like 2 courses. One of them is machine learning, which deals with text analytics, and the other one is the data analysis that we are having. Most of the students have this semester. So we have
what kind of stats in there?
We were like last session we were thinking about like machine learning. We were talking, I mean, the professor was talking about machine learning, but he's talking about like different type of analysis. So we are getting there, but some of us had like a statistic before. I don't know about all the students, but we are having like some courses that are related to analysis. And
when you say getting there, what do you mean?
So we have the course right now, so we have to wait till the end.
Oh yeah. But I mean, what are you talking about like right now? Are you talking like ANOVAs? Are you talking about measures of spread? What are we?
I can clarify because I have my undergrad was in math and statistics, and I'm in the TIM program, and there's no real talk about statistics. There's some algorithms and stuff, but no ANOVA analysis of variance or spread or
No spread. Oh crap. So was
Yeah.
this?
There's none really required. I think a lot of people know some because most people are from technical backgrounds. They probably had to take a couple of statistics classes, but yeah.
Okay.
Yeah, I think what Samantha said, I agree to it. The kind of statistics or the mathematical portion is more of visual programming that you get to use Orange and then you drag a stuff here and there. And it's more of an applied machine learning and not a hardcore machine learning where you need to know all the maths and then figure out all the linear regression and then all that crazy stuff. So it's applied machine learning based on visual programming.
Exactly, yeah.
Okay, so we're really scratching the surface, not really deep diving into.
Pretty much.
Okay,
Yeah.
I didn't know if you guys needed a deep dive in stats or not, because where it's applied, when you're doing with anything with data analysis, that's where it's applied. But if you're not actually deep diving into data analysis, you're not going to need to know whether, you know, the multidimensional scaling, how a multidimensional scaling works. So I talked about from a theoretical standpoint for a lot of the videos, but I don't know if that was, if it made any sense to you guys at all. I don't know like if you know what interquartile range is and that sort of thing. I don't know if I don't know how, if there was any particular part of the stats lectures that was confusing to anybody so far.
Not yet.
Not yet.
Not yet. Okay.
I think most of the TIM students have taken some sort of stats class in their undergrad degree, at least.
I think we lost Renee, did we? We lost Renee somehow. Oh, that sucks. Okay, she's going to tell us, I'm assuming, when she comes back in. Yeah, because I mean, I've taken like 5 stats classes and then had to retake the same stats class like 5 different times, because every time I learn, I'm like, yeah, I don't remember any of that. So I'm hoping it's not a waste of your time, but let me know if there's something that I can try and unpack or clarify. But it was meant to be a grab bag of different statistical stuff that is directly applicable to what we're doing, like how you find clusters of information, how you categorize things. That's what you're doing in the machine learning algorithm, but you're also doing it for visualizations when you're trying to map it into a 2-dimensional space. And so the party vote system that I talk about, which is an actual system I made for a research project that I did, is trying to map music onto a 2-dimensional space. And I'm not going to say that it was I used the right algorithm or anything. But that is one of the approaches you could take. And there's a whole bunch of different ways you can try and take what is essentially this really complex high-dimensional space and sort of squish it down or map it down into another dimensional space. And so that's part of the assignment set. All right. Renee, you got cut off. Sorry.
Sorry, my laptop just crashed.
Oh.
Yeah, lovely.
Yeah, I've been having that sort of thing. So you're saying not necessarily hardcore stats background. I won't push your laptop too much by asking for a whole lot of information, although I'd like to hear more information about that. Okay, so that's at least what those series of stats classes were. Please pull me back or tell me to clarify things if there's something that really is not making sense. I don't know if you had exposure to that or if I went too fast on a lot of those things, but I'm hoping it sort of worked for you. And the machine learning algorithm stuff, I'm assuming you got hopefully a deeper, if you've had to take it for the TIM program, you've gotten a deeper understanding of what the various types of machine learning, approaches there are and how they apply. But we're not doing machine learning. So these are tools that you have in your toolbox. They're not the focus of the course. So if you're doing a multidimensional scaling, great if you want to do it, but that's not the point of what we're doing here. Let me see if I can share my screen. All right, I'm going to do that. And I need to actually go back here. All right, so I don't know if there's anything in particular that you guys were hoping to go over because we talked about descriptive statistics. one of my pet peeves, in case you wanted to know later on, if you make assertions about numbers and they're not validated. So for example, this person used our system and it took them 4 seconds. This other person used our system and it took them 4.5 seconds. Therefore, our system is significantly better than the other system. I will laugh in your face, right? It's knowing how the statistics work tells you how you can interpret and understand your data. So understanding what a normal distribution is. This is the bell curve, right? When we talk about bell curving in university classes, or if we have a skewed normal distribution, and how we can describe measures of spread. We'll get back to this when we get into visualizations, because there are things like a fiddle chart, for example, where you actually are trying to display that distribution. If you're trying to figure out distribution for people that are immigrating to Canada, and you're trying to figure out the distribution of their skill set compared to jobs available in Canada, or compared to the requirements or the needs for the jobs in Canada. Or if you're trying to look at various events and the frequency of people scheduling events at this particular time throughout the run of the week. These sorts of distributions come in handy. They tell you a lot more of the story than just the average. So these are the kinds of things that I was hoping people would end up thinking about. Like, if you have something that's very skewed, you have to sort of keep in mind that if it's really skewed, for example, Thursday evenings might be the most popular event time. Do you put all your events in, or is it really an abnormal thing, right? And then we talked about how we deal with all these sorts of things. We're not going to be talking about ANOVAs, but we did talk about measures of spread as on top of that. What I wanted to get to, we talked briefly also about different data types and how that also relates to our look at analysis. From the videos themselves, I talked about the different types of dimensionality reduction. This was the first attempt at doing these sets of lectures, so if something didn't ring true for you, please let me know. But really, we have two types, which is we align our data so that it fits into a particular way. So that would be like principal component analysis. You figure out the dimension that best describes your data, that gives you the best distribution of data, so that you can so that it's not all packed in. So principal component analysis might be like the length of the song is a really good indicator of how good a song is, or let me think of a good idea. The academic impact, or the number of publications, is the best description, one of the best descriptors of, it gives the best amount of spread and distribution of academics when you're looking at people publishing during COVID. If you can find a dimension that best describes your data, a single dimension or a composite dimension, that's ideal. Or you could just squish it down, which is just, you sort of have this force laying algorithm where you push everything and try and have if you push all the data into a two-dimensional space and then let sort of a push and pull based off of how similar things are, you'll get a two-dimensional layout. When we get down to it though, and we can talk about manifold detection as well, and the various things that we do. So this is something from UBC, for example, that I think I was a user on one of their studies. Essentially, these things, with a really large data set, it's very hard to lay things out. And so allowing a user involved to steer how one of these algorithms works can actually greatly impact the the accuracy of your data. If you have this crazy number of data points, what you might want to do is say, I want to focus on this subset of the data points and lay out those, instead of trying to do all the data points perfectly, right? You're trying to get the general structure of the data. And then ISOMAP itself is another new technique that's actually really quite good because it actually gives you the general structure of the data while keeping the local neighbors correct. And then we can just say, we're going to leave it all in, and we'll look at both of these very soon. This is it's a matrix of scatter plots. So a scatter plot matrix, there you go, SPLOMs. Scatter plot matrix for a diabetes data set. So what the idea is, I take any given set of dimensions, and I have this dimension, the weight of the user by the weight of the user. That's why I don't have to show it. It's a correlation. It might be the weight of the user by the height of the user. It might be the weight of the user by the glycemic index, or they're not glycemic index, their blood sugar level at any given time. It could be the height of the weight of the user and some other thing. We will get the same thing on this side, where the weight of the user is on the other dimension, on the other side. And so this scatter plot should look exactly like the other scatter plot on the exact diagonal to it. And with that, it allows you to see a whole bunch of these comparisons all at once. Rather than trying to shoehorn it into like a three-dimensional visualization or something, you can lay everything out. And the real kicker for this is if I start highlighting things in one of these scatter plots, it highlights in all the other scatter plots. The same data I select in one gets selected in all the other ones. And so I can see the connection between these different dimensions. Okay. But this is, and if you didn't have a chance, I just like looking at the slice drop visualization. It is a slice of the human anatomy, and you can actually look at the various organs and stuff. It's pretty, and I think it's really cool. Let's see what we have for chat, and then I'll get to what we're actually going to go over. Yeah, ew is right. Oh, I love that as a group name. Thank you, Group A, the Standard Deviants. I love it. All right. So nerdy. I love it. Super Freakonomics. So this is the activity I was asking for people to work on. And if you haven't done it, we'll just talk briefly about it, but then maybe you can work with other people afterwards. So if you had Twitter data, it's actually really, 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 really rich. And you want to look at how things are connected, maybe based on a particular thing, like looking at the presidential election, or maybe looking at tweets related to a natural disaster. They have a large number of dimensions, some of them being tags, some of them being the text itself, some of it being the time it gets posted, some of it being certain images that you have. There's a whole lot of different data. And there's also relationships between the tweets, because you can, is it forward a tweet or tweet a tweet, or I don't know. There's probably some fancy pants terms for Twitter for when you pass a tweet on to another person, right? So if you're referring to another person's tweet, or they're referring to your tweet, there's a directionality as well on that. If you actually know the other person, if you're following the other person, if they're just a random stranger. So there's a whole bunch of different dimensions you could show about Twitter and the relationship between people. And the question is, what could you do? What kind of visualization would you want to make for tweets, and what kind of things could you show? So I'm actually going to pull this up. That's the reason I did all of that. So let's see, Philippe. Okay, tweets, what type of data do you have? Every tweet is built in demographic information, person who tweeted, country, city, great. Notice we have the country would be categorical data, the city's categorical data, the person presumably also categorical data, the date, which is, I'm assuming would be interval data, or like discrete data. Then we have the tags themselves, which may or may not be presumably categorical data as well, but it's also messy or unstructured. The text itself, you can find exact word counts and things along those lines. External videos, websites, yep. And files. Do you have an image? Oh, nice. Nice. Yeah. No link diagram is one of the classics. And since it's high dimensional space, how do you lay all those out? You have, beyond a certain point, these things are not connected and remove it. Or you could say this person directly references this other person, and then you can show that in a no link diagram. And this could also be, is this a word use frequency?
Yes, sorry,
Yeah.
that's mine. That's an idea that I took from a New York Times chart. It was made for them. It was about word counting. So across the time, how many times do you use a specific word?
Oh,
So it's very interesting. For example, if you do some study about the use of words in specific times, for example, close to elections from some politicians, and well, that was the idea. I just took an example that I found, but yeah.
nice, nice. Yeah, that's perfectly good example. I like it. Right? These are all. There's more data than you can possibly try and show. So you sort of have to pick your battles and what you're trying to show from this. So that's really nice. I like it. I'm going to see if I can get one other thing for my stuff. Twitter sunset visualization. I should have shown it to you guys earlier, but let's see if it does actually this. I don't. It doesn't show it automatically. I don't think. Oh, there it is. Oh, except for Microsoft sucks. Okay, so this is references to sunsets in various countries for various languages based off of when the tweet actually happens, with the time of day in this axis. These are one, two, three, four, five, six different cities. In some of them are along the equator, some of them are northern in more northern climates, and each of them is a year along this bottom axis. So this is tweets with involving sunsets and their frequency per year per city. And what you notice is this is New York City, this is London, the first one's London, New York City, this one is Indonesia, this is Colombia, this is Chile, I think, and this is Australia. Notice the pattern though. It goes up and down. Versus this goes down and up. Why? Because when the sunset actually happens, changes during the year, and whether you're in the northern or southern hemisphere makes a difference. I mean, it's obvious, I guess, to a certain extent, but it is a visualization of Twitter references to a particular word based on time. So that was something somebody did. I mean, I actually like yours more than that. Let's see, tweet visualize. What data do you have? Arts. By the way, this is exactly what I will love for these little activities. It's meant to be quick and dirty. It's not meant to be something that you hum and haw over or panic over, right? One of the ways you limit. So do you want to walk me through this?
Yeah, actually, what I write and what I understand is based on the course I had last semester. It was a natural language processing course, and we had to like work on the tweets and filter them based on the stop words, based on the hashtags, and based on some languages and characters. So I thought maybe like I can look at this in class activity like that. So what I write down is like to the question that how can you qualify all the dimensions. I thought you're mentioning that how can we limit like that amount of dimension. So
that's perfectly, that is one of the things you can do for dimensionality scaling. You can reduce the number of dimensions. That's perfectly fair. The question is, the machine learning algorithm might find things for you, but much like a neuron, it doesn't necessarily allow you to backtrack and see how it got to that point, right? It's not like categorization where you say it is this categorization because of X, Y, and Z. This musical style is based off, I'm trying to think of a good example. The Manchester sound, like from Britain, like in the early 90s, I guess. It's based around Manchester, the city. It is a particular time period. It has a particular style to it, and anything that, and it falls into a particular category. And a machine learning algorithm is not going to give you the Manchester sound. It's not going to categorize it based off of the historical context and a lot of other things. It's just going to say these songs sound alike, and it's not going to give you any kind of sort of holistic view of where it comes from or what it's actually referring to. It's just going to be like, it sounds the same.
What I said here to we can visualize was like based on the hashtags that a user like compose, we can say that how much he or she is like following the news, or based on the likes and the following members, we can say how how much influence she or he has on the society, maybe.
The impact, the Twitter impact rating would be is extremely useful, and it's something that you can display to people, and it's a summary of their data and who they're connected to, and you might want to display it to me. I'm not sure you can make the inference about how well informed they are about the news.
Yeah.
You can make inferences about other things, but like it might suggest that they're not informed, but you can't actually necessarily state it for sure. But links, so tags and examples, qualifier dimensions. Okay. Do we have pictures or anything like that? Okay.
Yeah,
There you go.
just right.
Nice. 2 different ways to visualize the relationship between tweets and the individual. Okay. Oh, nice.
I mean, I maybe I don't explain well, but I mean, like, based on the number of tweets they have on climate change or COVID subject or Thanksgiving or Easter, these kind of things. We can know what kind of person maybe they are. Are they like politics fan or events fan? I'm not sure.
I would actually like to know, though this brings up another point, I'd like to know what correlation there are between the tags.
Yeah.
So if I look up COVID, what are the related correlated tags to COVID in terms of, like, I put COVID, I put the related hashtags to that and how many steps off I am from that, or how many things are co-tagged with COVID. So Thanksgiving and COVID, right? And if there's how many steps there are in that respect versus the individual user, the patterns in how people find tags. Because quite frankly, I'm an old guy. I don't know how people are finding tags, but I know it seems like a very messy and error-prone thing to choose the right tag to make sure that other people find your stuff.
Yeah, and I think we can like visualize the sentiments as well based on like COVID Thanksgiving and the sad tweets that people have. Yeah, because they can gather maybe. That could be another.
I would also say emojis, the use of emojis and related on individual people, the frequency of emoji use versus the person. Something interesting, at least. Nice. I like it. Let's see what other things we have. And we're going to almost be done soon with time. Oh, Hansi, you went all fancy on me. Although I like the doodles. I love the doodles.
So should I explain it? So what I was thinking, because of the text analytics course that we had in the summer, we were like converting the number of words in each document, like in tweets, to numbers, and we would like make a matrix, so document term matrix, and then we would analyze that. And we would like decompose the document. First, we would weight them because some words tend to, so we have to prepare it. So like eliminate like punctuations, like put the word into the root of them. Like for example, turn the verbs into nouns, turn like the adjective to noun, so that the numbers would like make sense. And then we would, after like converting and preparing it, we would like weight them because some words tend to come more, but they are not like the ones that we are interested in. So again, weight all the numbers. Then we would decompose the matrix into 3 matrices. So one of them will show the topics that tend to come. One of them will show the documents that are more important, and the other will link them both. So we can visualize, as soon as we know the documents, the tweets that are more important according to each like individual, we could like take a look at in those documents and see what are the topics that are usually in those documents, and we could like visualize them like in the second one visualization. But the first one shows like another way to do so is like putting them in 2 groups. They are either positive or negative. So based on the words that they use, the message could be like positive or negative. And we could just see over the time how it changes from very positive to like very negative, and group them and see, for example, what are the times that people are usually putting positive messages, and what are the times that they are usually negative, and like what could be the cause. Like for example, during the COVID, most people are like a bit sad, so maybe they would like post more negative ones. But for example, during the Christmas or Thanksgiving, they tend to like post more positive tweets. So we could figure out like what are the times that people are happy and or sad. So
one of the things is you don't know if it's necessarily time, but it's a good thing to look at first. And so part of what we're looking at is I want to have positive and negative correlations, and then maybe I want to say what other dimension I'm trying to choose, and I choose a dimension. So it could be time of day, it could be time of the year, it could be the topic. If I choose an individual topic or a series of topics that are correlated with this, and see if I can get a correlation that way. Politics versus talking about your dog. All of these things they're very open-ended, and it depends. Like there's too much. Again, Twitter has too much data. What you're trying to tease apart, what you're trying to figure out, might require a lot of background analysis, but background processing. But once you have it, you still got to have this human involved, because you're saying the most. How do you choose the most impactful tweet? What's the most impactful tweet or the most forwarded tweet of all time?
Yeah, I have to interpret. So someone.
Do you actually know what the most forwarded tweet was?
Again?
The most popular, most forwarded tweet of all time.
I don't know, because I don't use Twitter, so that's why I only like take the text part and like talked about that and figured what it could be.
Oh, that's a new one. I didn't know. There's probably a bunch of other things that I don't have. Anyone that can. I'm assuming is
this not the thing that crashed
Japanese.
people's phones? There was
is that what? Seriously?
Text that crashed people's phones, yeah, and people were sending it to everybody because they thought it was hilarious.
Oh no! Seriously?
Yeah, because
What's
I think
most
it
liked
wasn't...
tweets? Oh god. Okay, I was thinking the. Oh, Twitter's most liked tweet was Chadwick Boseman. Damn it! I don't have the image of it. Hopefully, there's an image of it. There it is. That's the one I was thinking about, though.
Oh, yeah. I knew about
This Ellen DeGeneres photo, though, does not follow. If you used a machine learning algorithm for it, you would say people in a group make a popular tweet, because this one photo is was at least the time the most popular tweet or most forwarded tweet of all time, because it's all of these celebrities all in one selfie, and that's sort of incredible. But that's a very anomalous thing, and that there's another piece of the puzzle that is not part of what Twitter's actually presenting, right? Although you would get their celebrities, and that's the people that are forwarding these things on. But that was the most popular or most famous, like the most forwarded tweet of all time, I guess. Yeah. So I always think of that whenever people are like, well, we don't need the human. I'm like, you sort of do, because you're going to think of this as just people in a group, right? Maybe you might not need the human.
The topics, we need the human. So the machine will give us like bag of words or something like that. We have to make sense of those.
And there's some guidance along the way by the human, but the machine can do a whole lot of that stuff, but it's not at that stage yet, at least, to just do everything on its own. The machine is part and parcel for that. So I think there's a part in one of the machine learning algorithm where I find it fascinating that the speed runs on Mario, and I'll see if I have the speed runs on Mario. Yeah, I love to putting that photo in there if you didn't see it already. There you go. So what you're seeing on the left is a human playing Mario, if you can believe it. Yeah, that's a human playing Mario. And on the right is the computer trying to play Mario. It is nowhere near the human in terms of this crazy thing. The machine, the human playing Mario is using machines to help, trim down certain parts of their code. But they're not actually using a machine learning algorithm or anything like that to figure out the optimal speed. And if you take a whole bunch of speed runs and you sort of amalgamate all their times, then you can get a machine to do, follow a particular pattern, but it doesn't figure it out on its own necessarily. And so I think there's something interesting about getting the human involved and having this sort of machine as part of this whole process.
Human should be in the loop.
Yeah, that's my view, but then I'm biased because I do HCI stuff. So let's see. I think we're out of time, actually, so I don't want to. I've been holding you guys up more and more each time, so I'm just going to bring up Tina's just to show the awesomeness that is this. Nice, and friend networks and subclusters of it. You're going to run out of clusters, though, Tina. But have anything quick to say, and then we'll call it a day.
Yeah. And this is the friends network. I think when we sketch each person's friends network, then all the people around the world can be related together since we have mutual friends. So I wrote something there. I think this is because this is why the Earth is round. We are all related together through our friends, and this is what I think it is very interesting for me in social networks, all the social networks, Facebook, Instagram, Twitter. And for Twitter is always more rich because the data set is rich.
And it leaves it to a lot of really great interpretation, but you'll notice with this social network, you had to choose a very small subset of all the possible.
Yeah.
So as this gets big, these networks actually becomes another computer science challenge of how you present this network for people to make sense of it. And I think I mentioned to Renee in some kind of post or something, I have a friend that does this for like really, really large networks. That's his sort of area of expertise, just how to present it to people, because it becomes unmanageable for people to understand these sorts of things. So very nice. I'm loving all this stuff, by the way, guys. So keep up the good work. I'm going to let you go because I took too much of your time yet again. Sorry. And we'll pick it up next time around. Next time around, we're about to go to data searching and seeking behaviors, which I keep on referring to. And then we're going to start doing human factors after that. And so I'll be posting those videos soon once I, record the rest of them. And then we'll go from there. All right.
May I know what time will be the class next session?
Next Thursday? What? Sorry.
What time will be the class? Because last time you said you will make it earlier.
Yeah. So yes, you're good point. Thank you. My view on this was like, you guys are already drowning in stuff. I would rather cut down some of this stuff, like the if the synchronous class just covers the required stuff, and I don't I try and streamline some of the work in the future. Hopefully we can just stay at 10:30, because I was last week I was saying this because I was thinking like, yeah, we can add more classes, and now I'm like, no, they don't have time for more classes. So I'd rather keep it lean and mean for you guys if I can. And I go over time, I know, but maybe you guys can yell at me at 11:20 to shut up or something, because I want to make sure that you're not spending all of your time on this class. That makes sense?
Yes.
Yeah. Okay. So I'm going to stay at 10:30 for right now, at least. And then if I need, if there's a lecture that I need a little bit more time, I might make an announcement on that one.
Okay.
All right.
Thank you.
Great. Let's stop my sharing. Okay. I'm going to call it a day. Well, I have office hours now, so if you have any questions, please just poke me, and I'll chat with you. All right. Thanks, guys. Have a good one.
Thank you.
You too.
Bye.
Thank you. Bye.